Hi, College Algebra. We are starting Unit 2. We've survived a whole unit of College Algebra. You guys are doing great. Chapter 2 is starting, it'll start out a little familiar, just like the last chapter, though. As you'll see, we do go in a little bit more depth, a little more application problems. I hope you read the unit overview. It'll explain to you, why functions are important in the real world, where they're used a little bit, etc. We're going to start off with just a refresher on what we mean by function. Okay, I don't have the definition here. You've talked about a function in almost every math class you've had since Algebra 1. A function is a relation between two variables. We decide to say X and Y most often, but you can use whatever variables you want. There's an input and an output. A relation is a function as long as every input is matched with only one output. Okay, so you can't have repeated X's, for example, is one way we say it. Okay, so a line y equals x minus 4, fantastic. That's a function. I think you remember that. This set of ordered pairs is not a function, is it? 3, sometimes I put 3 in for x and I get -2 out for y. Other times I put 3 in for x and I get 4 out for y. I can't be unsure about what I'm going to be getting as a result when I put the same number in. So that is not a function. Okay, that's not going to happen for y equals x minus 4. If I put 5 in for x and take 5 minus 4, I'm going to get 1 for y every time. Okay, so that's why that's a function. Oh, number 2. X squared plus y cubed equals 8. Boy, that's a tough one. Not really familiar with what that looks like. Are you? When we have something that we're not sure what it looks like as far as the graph, you want to look at the variable on the y coordinate, okay? If the variable on the y coordinate is even, then that means that there's going to be two different y's for the same x, because 2 squared is 4, -2 squared is 4, right? You get the same. So you want to make sure that the variable on y is odd, okay? X squared plus y cubed equals 8. Boy, that's tough to think of. Let's graph it. I often refer to Desmos. Please use it. Oh, it's just a wonderful tool. I can just type it in here, unlike my graphing calculator, which, we can't have it in terms of y. X squared plus y, whoops, I don't know why I did capital, sorry. Y cubed equals 8 is what we were thinking of, okay? So if I come over here and look at that graph, goodness sakes, isn't that funny looking? We're going to get into all these kinds of fun functions that you're not used to. Okay, there we go. And as we learned before, if I could drop a vertical line and hit this twice, then it wouldn't be a function, which I know this is looking like, oh, I can't, that's not really a vertical line, okay? It's curving. And so anyway, that is a fine function. All right. So we can go ahead and say, yep, that's a function. This looks like a function. -5, 1, -1. Fantastic. 3 functions in a row. We have this table. Oh, goodness. I have a 1 listed twice, not a function. X equals -5 is a vertical line, not a function. Okay. Let's see, going back over here. Oh, I see my y squared here. 3x minus 2y squared equals 8. I might want to look at that. 3x minus 2y squared equals 8. Let's check that out on Desmos. 3x minus 2y squared. Oh, it was equals 8 again. I'll just keep that there. Okay. 3x minus 2y squared equals 8. All right, if I look at this, oh goodness, it's one of those, I don't know, I sometimes call them sideways parabolas. It's a sideways parabola. And so if I drop a vertical line straight down, I hit it twice. No, thank you, not a function. Okay, so I am going to give that big heave-ho. Not a function. Sorry, I'm trying to arrange my screen back to where that looks good. Okay. So that's not a function. This is a circle, straight down, not going to be a function. Y equals 9 is a horizontal line, so that's fine. Okay, so you're going to have to look, again, I think you're fine with graphs and tables and ordered pairs. You're used to not looking for that repeated x. What's going to be a little bit different are when you have some equations that you're not used to. And what I'm telling you is to look at the y variable and look at the exponent on y. If that exponent is even, you're not looking at a function. Okay, it doesn't matter about x. It's the y that cannot be even. If it's to the third or to the fifth, that was fine. When it was to the squared, that's not fine. Think about this circle. We remember, we just did circles. I don't know, it looks like, I don't know what the center is, but it's something, you know, x squared plus y squared equals whatever this radius is squared, right? So the y is squared. That's why that's not a function. Okay, so that's the first part of this. The second part of this is looking at all the different functions. Guys, we're going to be looking at all of them that you studied in Algebra 2, some of you in pre-calc. Okay, we're looking at all of them at once and looking at how we're going to be making comparisons, all kinds of things with these functions. What I want you to see with what we're going to do next is that no matter what the function, this first black one is a linear function, okay? A linear function, we know what y equals x plus 2 is. We're going to be up here at 2. Slope of 1, so I'll go up 1 over 1. Okay, there's x plus 2. Okay, it kind of looks like y equals, y equals x would be down here at 0, 0. It's just kind of shifted up 2. The red one, y equals x squared plus 2. Y equals x squared is a parabola. This is y equals x squared plus 2. So let's think about it. If I'd put 0 in, I'd be up at 2. If I put 3 in, 3 squared is 9 plus 2 is 11. Okay, negative 3, same thing. Negative 3 squared is 9. I get 11. Okay, I can't really graph that, but I know I have a parabola here. I'm just trying to sketch them right now. Okay. Square root of x plus 2. I don't know if you're familiar with the square root function, but you will be after this class. My domain for my square root function are only positives, right? I can't put, well, and 0. I can put 0 in, square root of 0 is 0, plus 2 is 2. I can put 1 in, square root of 1 is 1, plus 2 is 3. I'm going to put 4 in. Square root of 4 is 2, plus 2 is 4. Okay, it ends up, you just kind of have this curve happening like so. Okay, it curves. All right. Absolute value of x, very similar to x squared in that it turns everything positive, but it just doesn't times it by itself. So 0, I get 2. When I put 1 in, I get 3. When I put negative 1 in, I get 3. You end up getting a v, right? Cubed root of x plus 2. 0, I'm at 2. Let's see, let's put 1 in, I'm at 3. Negative 1 cubed is negative 1. Plus 2 is 1. Okay, we got this little curvy. It's similar to square root, except I'm allowed to have negatives. So it's kind of shifted up like so. X cubed. We have x cubed. Let's see, 0. Oh, I meant x cubed. Sorry, plus 2. When I have 0, 2. 1 cubed is 1 plus 2 is 3. Negative 1 cubed is negative 1 plus 2 is negative 1. We get a curve that looks something like so. And again, we could do this on Desmos as well. What I want you to notice is it didn't matter if it was linear, quadratic, square root, absolute value, cube root, cubic. When I added 2 to it, whatever the shape of it was, it got shifted up 2. All right, that is a transformation that is standard, doesn't matter the function. Linear, quadratic, square root, absolute value, cube root, cubic. You know, we're going to get into exponentials and logs. If you stick with me with trig, we'll do trig functions. And it doesn't, all those, if I add 2, it moves up 2. Okay? Now, let's see how it's different if I add 2 on the inside of the parentheses instead of, you know, do the function to it and then add 2. Okay, what if I take x plus 2 in parentheses and square it? Well, let me think here. 0 plus 2 is 2. 2 squared is 4. 1 plus 2 is 3. 3 squared is 9. Oops. Negative 1 plus 2 is 1. Squared is 1. Negative 2 plus 2 is 0. Squared is 0. Negative 3 plus 2 is negative 1. Squared is 1. Negative 4 plus 2 is negative 2. Squared is 4. I'm seeing the parabola. So it looks like it takes x squared, what, you know, x squared used to be, and shifted it to the left 2. Let's see if that's standard, that works for square root of x plus 2. When I do square root of x plus 2, I put 0 in, I get the square root of 2. Ugh, I don't feel like graphing that. When I put negative 1 in, negative 1 plus 2 is positive 1. Square root of that's 1. When I put, I can't go too much. Well, I guess I can put negative 2 in. Negative 2 plus 2 is 0. Square root of 0 is 0. Can't put negative 3 in because that gives me the square root of negative 1, which isn't a real number to graph. So I have negative 2, 0, negative 1, 1, 0, square root of 2, which is about 1.4. I guess I'll put 2 in because 2 plus 2 is 4. The square root of 4 is 2. So 2, 2. It's the same square root function, just again shifted to the left 2. Absolute value of x plus 2. Let's see, let's do some green down here. 0, I get 2. Negative 2 plus 2 is 0. Square root of that's 0. Negative 4 plus 2 is negative 2, but the absolute value, that's positive 2. So negative 4. Okay, so I'm seeing my v. And again, it's a v just like it was before, but I'm shifted to the left 2. X plus 2 cubed. Well, let's see. X plus 2 cubed. I put 0 in. 0 plus 2 is 2. 2 cubed is 8. Okay, up here. I put 1 in. Oh, that's going to be too big. Kind of. Let's go to negative 1. That gives me 1 cubed is 1. Okay, and etc. So negative 2 gives me 0. Negative 1 gave me 1. Negative 3 gives me negative 1. So I have that same shape, but again, to the left 2. So it looks like adding 2 on the inside shifts us to the left 2, no matter what our function.